Hello everyone, this is Zijia from INFOSYS735 Group 18, and our group members are Simran, Ishan, and Yijiang. We will present a cloud architecture solution for the Go Green Insurance Company. In what follows, this solution has been divided into 4 sections. Firstly, we will show the configurations of VPC, subnets, and AZ, net server instances, and network ACL. Secondly, we will show the security groups, EC2, and S3 bucket settings. Thirdly, we will present the configurations of ELB, auto-scaling with SNS and CloudWatch, and web servers. Finally, we will provide our additional components in our solutions, which are RDS, CloudFront, and Route 53. Let's start with VPC.
For our VPC, we have implemented in US East 1 as its demonstration purpose because due to the lab environment, availability zones are limited in US East 1 and US East 2 only. We are not able to set up our VPC in US West 1, and we have set up the IPv4 CIDR range for 10.0.0.0/16. And for the subnet, we have created 8 subnet in total, 4 in each availability zone. We have set up a public subnet facing the internet and 3 private subnet in web, app, and database tier. And the rest we can see it's automatically generated from the RDS database. And we can see our public subnet is already associated with the public route table, and we have attached a internet gateway to grant internet access. And as our instances are all located in the private subnet, to grant internet access from them, we have also created a NAT gateway for each of the public subnet. We can see the NAT gateway 1 and NAT gateway 2, so they are assigned to each public subnet. To control inbound and outbound traffic, we have also set up a public network ACL and a private network ACL. The public network ACL is controlling the traffic coming from the internet, and we can see it's allow all traffic coming through 0.0.0/0. And for the private network ACL, we can see the source is 10.0.6.0/24, which is the public subnet.
Next, for EC2 configurations and security groups, each tier has an EC2 instance. For example, web tier is the Go Green web server instance in the private subnet. Application tier is the app server instance in the private subnet. Database tier is the DB server in the private subnet. The app server and DB server are actually dummy servers for now because we will implement in the additional components section. And also there is another instance called Bastion host. It is used to connect with the RDS database in the additional components section. Due to the limits of lab environments, we can only choose the free tier type of EC2 instance, which is T2.macro. This will be different depending on situations during the actual implementation. So for security groups part, we have set up security groups such as ELB SG. The inbound rule of ELB security group is that enable internet access on port 80, and web security group, which is used to enable internet access and allow access on port 80 from ELB SG. App SG allow access on port 80 from web SG. DB SG allow access on port 80 from app SG and port 3306 for connecting with RDS database. And Bastion SG, it is used to allow RDS database connection. And for other SG naming RDS-EC2, it is what RDS services automatically generated. For our S3 bucket configuration, we have created a private S3 bucket and implemented the data security by enabling default encryption and server-side encryption. Also, to meet the company requirements, we also implement lifecycle policy. There are two policies. Firstly, the objects has not been modified for 90 days will be moved to Glacier instant retrieval. And the second rule is that after 5 years, the store object will be permanently deleted.
Next, I will talk about ELB, auto-scaling group, including SNS and CloudWatch, and web server in our solution. First, Elastic Load Balancer is used to make the request be distributed to different instances to be processed and to ensure the system performance. And here is our setting for the load balancer. For application tier, we can see the scheme is internal, and for the web tier, it is internet facing and in the public subnet and private subnet. Next is auto-scaling group. When there are more requests from the users, the instance will be launched to ensure the system performance and to reduce the latency. We set the maximum capacity at 4 to ensure the performance. Both web tier and application tier use the auto-scaling group. For our web server, let's check the configuration of the web server EC2 instance. Also, in the user data, we can see the script loads a test page to show if the web server working properly. Let's connect to the ELB DNS name to check if the ELB autoscaling and the autoscaling group and web server are working. We take a load test and to the web server and refresh the page. We can see the traffic is sent to different AZ, and also we can see the instance created by auto-scaling group. For SNS services, we set SNS in our auto-scaling group configuration, and it can notify us the 4 event types of whenever instance have. And this is the notification email sent to our Gmail. For CloudWatch service, we also set it in our auto-scaling groups configuration. We click the monitoring and we can see the different CloudWatch, both in auto-scaling and EC2. Yeah, just run.
Okay, so for the additional services, we have started with RDS. So we have created RDS using Aurora. Database resides in the private subnet so that it cannot be accessed from the internet. Only the application layer instances can access the database. We have used multi-AZ config for high availability. Now moving on to the next service, we have used Route 53 for the domain name resolution of the CRM application endpoint. We have used Route 53 because we can assign and access custom domain names in our virtual private cloud and using internal AWS servers and resources and servers without exposing DNS data to the public internet. Also, Route 53 is highly available and scalable. We have created the DNS record in Route 53 and the alias is pointing to our ALB. When we hit this endpoint, we can then access our application. The next service is CloudFront. So as GoGreen has its offices in South America and Europe too, the sales personnel there may face latency issues while interacting with the application. To overcome this, we have used CloudFront as a content delivery network to securely deliver data, web content, and APIs with low latency and high speed in a cost-effective manner. We have used the ALB as the origin for our CloudFront.
This is our group's whole demonstration of the architecture solution. Thank you very much for watching. We appreciate any feedback. Thank you.